Hello students, in the previous class we have seen the ionic product of water. So today let us discuss about common ion effect. So here we are saying generally common ion. So in the name itself, what it is indicating common. Common means what here? The ion, whatever electrolytes we are going to take, that is whether it is strong electrolyte or weak electrolyte, that should be common. Okay, the ion should be common. So that is nothing but common ion effect. The two ions, if there is a common, that one we call it as common ion effect. So this common ion effect mainly depends upon Lee-Chatler principle, which is the application of the common ion effect, and also depends upon equilibrium. Okay, so now let us see what is common ion effect. So I am saying that here the common ion effect. So this common ion effect mainly depends upon degree of dissociation or degree of ionization, which is indicated by alpha. Okay, so here the degree of ionization, the degree of dissociation or ionization I am taking here, the degree of dissociation of weak electrolyte what we can say here, the degree of dissociation of weak electrolyte is decreased or suppressed, whether we can say decreased or suppressed, by addition of strong electrolyte. We call it as what here? Having common ion we call it as common ion effect. Okay, so what I am saying here, the degree of dissociation of weak electrolyte. So for weak electrolyte, the degree of dissociation, how it will be? It is partially dissociated into molecules, right? So it is decreased. When you add strong electrolyte, automatically what happens? It is going to have the common ions. That one we call it as what here? Common ion effect. For example, I am taking here CH3 COOH, acetic acid I am taking. So this is a weak electrolyte. Acetic acid I am taking, this is what here? Weak electrolyte. So at equilibrium condition what happens? It is weakly dissociate, means it is dissociating it to ions like CH3 COO minus plus H plus. And next I am taking same molecule, that is sodium salt of acetate. Okay, so this one indicates what here? Strong electrolyte. Here I am taking strong electrolyte. It is dissociated into what here? CH3 COO minus plus Na plus. If you have been seen here, what is common in this? In this, the common ion is acetate. Okay, so this is the common we are having. So according to definition, if you have been seen, means the degree of dissociation of weak electrolyte. Okay, so this is the weak electrolyte is decreased. Why? Because by addition of strong electrolyte having ion common. So let us take in a beaker. I have taken in a beaker, see here. So here what happens? So in a beaker what happens? So in a beaker I have taken CH3COOH solution. Okay, so this is the CH3COOH solution. So when you add this one, when you add sodium acetate, so you are adding here what here? CH3COO Na you are adding. So then what happens? Generally it is forming as a precipitate. So when you add CH3COO minus, then what happens? Here the concentration is increasing compared to this one. This weak electrolyte is having low concentration and this strong electrolyte is having high concentration. So means what happening here, when you add this one in water, automatically the concentration is increasing. It is becoming soluble. But the weak electrolyte is partially changing into ion. So means the degree of dissociation is decreasing here. Means the degree of dissociation is nothing but what? Here the amount, means the amount of the solution in presence of electrolyte. So the amount of solution in presence of electrolyte is added. That one we call it as degree of dissociation. So what we can say, the dissociation is nothing but what here? The fraction of amount of solution is added in presence of electrolyte. That one we call it as what? Degree of dissociation. Okay, so this is about common ion effect. So I have told you it depends upon Lee-Chatler principle, right? So what is Lee-Chatler principle? So generally according to chemical equilibrium, what is the definition? At equilibrium, there is no change in the concentration of reactants and products. Right? At equilibrium, what happens? There is no change in the concentration of reactant and products. So when you apply some conditions, like concentration, temperature, pressure, then automatically the equilibrium will shift. Means the equilibrium will change. Okay. If you increase temperature, there will be a change in some equilibrium. If you decrease, then also it will be some change in temperature. Then will be also some change in the equilibrium. So like that, if you change some conditions like, means if you apply some conditions like concentration, temperature, pressure, like that, then what happens? Automatically the equilibrium will shift and it will nullify. That one we call it as Lee-Chatler principle. So what is Lee-Chatler principle? So according to chemical equilibrium, the equilibrium is constant at concentration of reactants and product. When you change the conditions like concentration, temperature, pressure, it automatically equilibrium will shift and it will nullify. So that is nothing but Lee-Chatler principle. So now coming to here, I have taken here acetic acid. Okay. So here when you take acetic acid, generally what happens? It is forming as a CH3COO minus H plus. So when you are changing the concentration of acetic acid, the equilibrium, here the concentration of products, what happens? It is coming backward and it is shifting towards left. Means the weak electrolyte shifting towards left here. That's why the weak electrolyte is decreasing here. See here, I have taken acetic acid here. So when you are increasing the concentration, the automatically what happens? The right side, at the right side of the product, means the product is coming backside. Means here what happening? The product is coming backside, it is shifting towards left side. For example, generally I am taking some molecule NH3, which is a Haber's process. Okay, so then what happens? N2 plus 3H2 gives rise to 2NH3, right? So concentration is nothing but what? Number of moles per liter. Okay, N by V we call it as concentration. Why? Because number of moles and liter. So if you have been take here number of moles, here the for N we are having 1, for hydrogen we are having 3. Total how much we are having? 4, and coming to here 2. So if you compare these two, see here here there is a more reactants and there is a less reactants. To get here more, we have to add again the moles, number of moles. So means what here? Here the concentration is decreasing, here the concentration is increasing. Here it is having more concentration. Why? Because number of moles is more. So here number of moles is less. So it is having what here? Less concentration and it is having more concentration. Okay. So then what happens? This one shift towards back side, means left side it is going to shift. So that is the thing, it is happening in the same thing acetic acid also. So when you remove H plus ions, what happening here? Automatically it is shifting towards left side. The equilibrium is shifting towards left side, which is a backward reaction. Okay, so this is about what here? Common ion effect. So now it is going to have some applications. So it depends upon nature of solute. What is the first application we are having? Nature of solute. Okay. So solute, which will be we have taken in the solvent. So now what happens here? The degree of dissociation of this solute. If you take strong acids, bases, and salts, automatically what happens? The degree of dissociation will completely ionized. Means alpha value will be completely 100%. Okay, so then you are going to get what here? 1 is the value. We have seen in the previous class also, that is degree of dissociation, and in ionic product of water also we have discussed degree of dissociation. And coming to weak acids, bases and salts, if you take the degree of dissociation, what happens? The degree of dissociation will be is not ionized. So here only now we are seeing that acetic acid molecules. Okay, it is going to form the dimer of the molecule. So this is about nature of solute. So whatever acid bases, if you take strong acid, strong base, strong salts, so what happens? The degree of dissociation is ionized. That one we call it as 100%. The alpha value will give 1. If you add any acetic acid or else ammonium hydroxide base, calcium hydroxide, so like that, if you add any salt and bases, acids like that, weak acids, so then the degree of ionization is not completely ionized. So then what happens? It is not giving alpha value 1, that is 100%. It is not given. It will give some value like 0.01 like that in minute things. Okay, so basing upon nature of salt also, the degree of dissociation will depend. So next application we are going to have is nature of solvent. So nature of solvent. So what is nature of solvent here? Generally, if you take electrolyte, so when you take electrolyte, whether it is weak or strong electrolyte, when you added it to the solution, so when you add it to the solvent, so then what happens? That it depends upon mainly dielectric constant. This solvent depends upon what here? Dielectric constant. So what is dielectric constant here? The dielectric constant is nothing but it weakens the force of attraction. What is dielectric constant? It weakens the force of attraction between electrolytes when immersed in solvent. So means what happens here? If you take two electrolytes, strong electrolyte, weak electrolyte, so the force of attraction between strong and weak electrolyte decreases. Why? Because when you add in the solvent. Okay, so here what happens then? The degree of dissociation increases. The degree of dissociation increases, then dielectric constant increases. If dielectric constant is increasing, the degree of dissociation also increases. Okay, so if you compare these two, solute and solvent, so here the number of molecules of solvent, the solvent molecules will be more when compared to the solute molecules, because when you apply some degree of dissociation value. Okay, and also if you take temperature increases, then also dielectric constant value increases. So it also depends upon nature of temperature. So here if temperature increases, what happens? The degree of dissociation also increases. Okay, so this is nothing but nature of temperature. And also if you take concentration, here the concentration is inversely proportional to degree of dissociation, we can say. Why? Because if it is increasing, the degree of dissociation decreases. If it is increasing, it decreases. So if you take less concentration, the degree of dissociation will be more. If you take more concentration, the degree of dissociation will be less. So these are about the applications of the common ion effect, we can say. And also if you take group cations, when you do cations there, see there, when you take cations, so in group 2 what happens? Generally in group 1 what we do to get the precipitate. So to get precipitate, what we are adding in group 1 cations, for group 1 cations we take original solution and dilute HCl. Okay, so if you get any precipitate, then we can say that it is a first group cation. If there is no precipitate, then what we are going to add there? We are going to add, for this solution, to the above solution we are passing H2S gas. See here what I am saying. So for group 2 cations, what we are doing? We are passing H2S gas to the above solution. Then if any precipitate comes, then we say that group 2 cations is present. So if you have been seeing here, there is a common ion in this. For H2S, there will be a S2 minus plus 2H plus. For HCl also there will be Cl minus plus H plus. So if you have been seen, there is a common ion in this, that is a hydrogen. Okay, so this is getting a common ion. For group 2 cations also we are getting the common ion. So then what happens? It is having the more concentration, means it is a strong electrolyte, we can say. We can say weak electrolyte. So means what here? Here it is having low concentration, it is having high concentration. And not only this, if you take group 3 cations, in group 3 cations what happens? You are going to add ammonium hydroxide, which will be divided as NH4 plus OH minus and NH4Cl, which is a strong electrolyte, NH4 plus Cl minus. Okay, so this is weak electrolyte and this is strong electrolyte. So what is the common in this? We are having the NH4 plus is the common ion. So here OH minus Cl minus, it is forming as a precipitate NH4Cl. So that one leave it. Okay, so if you have been observed here, we are having in group 4 also H2S gas passing, and including NH4OH and NH4Cl. And if you take group 5, in group 5 also we are going to take NH4OH and NH4Cl. And group 6 also you are going to take NH4OH and NH4Cl. So everything we are having, but only group 2 and group 3 is precipitating, and these are having two common ions. Even the group 4, group 5, group 6 having common ions, but they are not precipitating. Why? Because they are highly soluble compounds. Group 4, 5, 6, whatever you are taking that compounds. Group 5 compounds, what is that? We are having barium, calcium, strontium. And if you take group 4, zinc, cadmium, nickel, and group 6, ammonium, magnesium. Okay, so these are the compounds whatever you are taking that are highly soluble compounds, and they are not going, they are forming common salts also, they will not give the precipitate. So if you take group 2 and group 3, so these are having also common ions, but this will precipitate out. So because of this is one of the application we can say. So this is of the common ion effect, and we are having isohydric solutions. So isohydric solutions is nothing but, for example, concentration of H plus it is giving, whether in a HCl or HNO3, and also OH minus ions is giving in calcium hydroxide or barium hydroxide. So then what happens here, when you mix these two, HCl or HNO3 and calcium hydroxide and BaOH twice, so when you are mixing these two, these are not increasing and decreasing, means they remain, these electrolytes remain same. Okay, so these electrolytes, what happens, these electrolytes remain same, we can say constant. That one we call it as what, isohydric solutions. Okay, so this is nothing but isohydric solutions. So what is isohydric solutions? If suppose the H plus and OH minus ions, when you are mixing, the electrolytes remain same, that one we call it as what here, isohydric solutions. So this is nothing but common ion effect. In the next class we can discuss about solubility product. Thank you.